All right, let's actually work through the details of one where it doesn't work out. I just want to show you what happens. There's more than one way to see that something is not linear. It's either the first straight line that you draw fits all of the data points, or something that sticks out, and then either two lines have different formulas, such as, well, for this one I'm drawing this line, and then I'm drawing this line is what I want to do here. I just, if it doesn't match, it doesn't match. And then any way that you try to compare them something is going to stick out. So I just want to work through that here. So for this thing that I called line 1, I have the point where x is equal to 4. And I have also the point where x is equal to 2. So calling that line 1, and then this thing I'm calling line 2, x is 1, and then x is 2. So it's these 2 points on the graph. So let's just see that the 2 lines that we draw end up disagreeing with each other. And there's more than one way to see that the data set is not linear. Graphically, you can just sort of draw the picture and you can see it right away. You draw a line between 2 points and it fails to meet everything, but let's do it algebraically. So for line 1, what we've got is change in y, which is 2 minus 1 divided by change in x, which is 4 minus 2. So the slope is 1/2. So yeah, so the scale wasn't completely perfect, but it looks basically like 1/2 to the best of my drawing skill. And let's just use this point right here. It doesn't matter which one, but we have to be consistent. Once we pick this x, we have to use this y as well. So it has to be, like, you can't mix and match. It has to be, it has to be consistent, and then which one is x and which one is y is also important. But it's y minus, in this case, I guess I would call that y3 and x3. So the same point, but the y goes here, the x goes here. And the slope, well, we use 2 points on the graph to find the slope. We use 1 point on the graph along with that slope we already computed, to get the entire linear model that maybe it fits everything, maybe it doesn't. So we just distribute this 1/2. Well, now that we've distributed the 1/2, we can add 2 to both sides, and then since that 2 is no longer inside of parentheses, we can add 2 to cancel it, and we get that y is equal to 1/2 x plus 0. So the y equals 1/2 x is this line number 1. And what does this model predict? It predicts that when x is this, y is this. It predicts when x is 1. Well, here are the points that are supposed to match. You plug in, well, it's already failed immediately. If you plug in 1, and you're supposed to get -1, because that's the actual data, but the line predicts this stuff down here. When you plug in 2, you get you get 1 like you're supposed to. But you have to, you're supposed to get it completely perfect. So 3/2 is no good. And that, if I was just asking, is the data does the data set, does a linear model fit the data set? And so And no, it's not a linear data set. So from the point of view of algebra, it's either linear or it's not. It has to be perfectly linear, and it isn't. It's, you fit any 2 points, doesn't matter which two, and it doesn't fit everything. It fits only those 2 points we use to construct the line. And even if it fit one or two more, if there's still some hiccups, then it just doesn't. It's not linear. It just isn't. And so that's the end of the story. So, so one way of seeing it is that points on the line don't fit the first thing that you drew. That's the fastest way to do it. I'm having you explore it a little bit more. I just want to show you that not only do the points fail to fit the line, but if you use another pair of points, you get a different line as your final answer. So line number 2. So I'm just using the first two x values. So y minus, I'm using change in y over change in x. So 1 minus this one, so change in y divided by change in x. So it's nice to have it as a table, because if it's all, there's like a pattern to it, so it's just change in y, change in x, looks like that. And it's all matched up kind of in rows and columns, and you can sort of see directly that this is 2. So slope, nice slope of 2 there. So the line passing between these 2 points is going to be a different line than the line that passes through those 2 points, because it's not linear. But let's see that directly. So y minus, we can use y0 if we want. So whichever point's your favorite. The formula in the textbook just calls it x0 and y0, but if you've labeled your points differently, use whichever point you like. And what do we get? Well, 1 and then y0 is -1. I can add the -1 to both sides, or whatever, +1. I can subtract +1. So sure, if we plug in 1, we'll get -1. If we plug in 2, we'll get +1. But if we plug in 3, we won't get 0. We'll get +3. If we plug in 4, we'll get like 5 instead of 2. So it doesn't fit the same data set perfectly. So let's check out our predictions. So this is yet another contradiction. If we used a different pair of points, if the data really were linear, then we would get the same slope-intercept form of the line no matter what we did. The slopes would be the same, and the y-intercepts would be the same. But here, the first line crosses through at y equals, crosses the x-axis at what, or the y-axis at y equals 0. The second line doesn't cross to all the way down here at -3. So if it's not linear, it's going to be not linear, and there's more than one way to see that the pattern falls apart. But here, sure, we get plug in 1, you get -1. You plug in 2, you get +1. You plug in 3, you get 3. But you're supposed to get the actual data point. The model makes some bad predictions, and so that's what's going to happen. If one of the lines fails, then nothing is. No single line is ever going to work for everything in that case. Because there's only one line that passes through those first 2 points, and if it doesn't pass through everything, then your ship is just totally sunk there. That's it. So this is mostly familiar, but just kind of helping you think about what is the textbook actually asking? They use this extra language that might be a little bit unfamiliar, but it's mostly the same stuff. But it's just you have to look at the data and ask, does it fit or does it not fit, and that's all they're looking for here.